Hydraulics, the generation of electricity from the hydraulic energy have some different perspective in this case of the heat transfer. In biotechnology, ripening of the fruits or processing the biomaterial, it requires some heat transfer modes, and also in space energy, space applications. So when you know that one of the satellite is moved from Earth orbit to the space orbit, there is always a band of the heat transfer in between these two different things because space have no air and your atmosphere have air. So there is a difference between the band between this space and Earth orbit. So in between this one, there is a band of the heat. So it is very important that when any satellite or any launch vehicle can be enter from Earth atmosphere to the space atmosphere, so they can form a difference between the heat energies. So they have made applications of heat transfer in this space application also. Now next is heat. Always you know that flow from high temperature object to low temperature object, or heat flow stop when temperatures are equal, and various way by which the heat may be flow. So here's one of the example you see on screen. Heat flows from child into the air, so it's nothing but convection, we can say. Sorry, it's not a convection, it's a radiation. So supposed to be 37 to 30 is ambient temperature. Also heat flows from child and air into the ice cream. So 30 to minus 2 degrees Celsius, some heat to be convected, radiated, and some heat you say that 37 to ice cream it gained and removed. So these are the different ways of the heat transfer. So basically, these are the three modes of transfer for your syllabus, and it is only three modes in the heat transfer. It's called as advection, convection, and radiation. One by one, we see that the modes of the heat transfer, in which the first is the conduction, that heat transfer to the direct metal. If you heat one of the metal body in a one point, heat may be transferred to it to the second point of the object. So we have some media to transfer, so it's called as conduction. Second is the convection. Before going to the convection, we see that one of the radioactive exchange. So heat transfer via electromagnetic waves. So the best example is the sun waves, or these sun rays comes to the on Earth surface. In a radioactive exchange, there is no medium required to transfer. इसके लिए medium जरूरी नहीं होता radiation के लिए. It can also transfer in vacuum also, or you can say that from space to the Earth's surface. So no medium is required to transfer in a radioactive, or you can say in radiation. And lastly, the convection. So heat transferred by the moving fluid means by heat transfer by take means by moving particles. So particles, you see that on the screen, there is one of the pot and where the water is to be heated. And you see that there is a one red line, or in one is the blue line. So denser water can be moved from top surface to the bottom surface, while the less denser water or hot water can be moved from bottom surface to the top surface. So this is takes place, it's called as the convection heat transfer. Is by means of gas or liquid. So some examples we consider is that the convection, conduction, and radiation. So first is the convection, the transfer of heat through a fluid caused by the molecular motion. If there is a molecular motion, there is always a convective heat transfer. Now the second is the transfer of heat from one substance to the another due to direct contact. So if the this you can see utensil is to be heated, so this will be transferred from this surface to this surface. So have some media to transfer, and it is transferred from one substance to another substance, which causes direct contact. It's called as conduction heat transfer. The transfer due to molecular motion is called a convective heat transfer, and if the energy that is radiated or transmitted in the form of waves or rays, or in the form of particles, you see that. If you sit near this hot surface, so you feel that some waves, it is hot waves. It's called as radiation waves. So that is about the conduction, convection, and radiation. Also, you can see that if you are sitting one side of the wall, this is a solid body, you are at temperature suppose it is inside temperature is T1, you are sitting at T2. When there is a heating started from this side of the wall, so due to the heating surface, heat is transferred to the solid body, and you feel some temperature at the face B. It's called as convective heat transfer. Conduction heat transfer, and at the same time, as the T2 temperature is raises, you feel that the temperature of the phase B is too much hot. At the same time, some of the heat is to be convected to the air, and some of the heat is convected. It's called as air temperature. So this is one of the heat transfer in which you have to see the one of the example of conduction and convection, not a radiation. Also, there is some superency that this pool is there. So conduction is taken as in this case is 5% only. Convection taken as 20% and radiation is taken as 10 to 15% in this case in the pool, whereas 65% get evaporated. So during the evaporation process, some of the heat is convected, radiated, and conducted. Now, again, move to that point. It's called the three modes of the heat flow: that's conduction, convection, and radiation. In which conduction is the flow of heat by direct contact between the warmer and cooler body. So, heat flow from warm body to cooler body until the cooler body reaches the warmer body temperature. Then convection is the flow of carried by moving gas or liquid. So, simple example you can consider warm air rises and give up heat, cools, and then again falls. Lastly, the radiation is the flow of heat without need of any intervening medium. That is typically by infrared radiation or light. So this is called the Fourier's law of the heat conduction, in which heat transfer from one body to one phase to the another phase, the T1 to the T2, that is fall of the temperature, whereas the K is the thermal conductivity and delta is the distance between the two face of the wall. So they have to require for the solution of the problem. So Q amount of heat is to be conducted from one of the media. And for that case, we consider the cross-sectional area A for it. So the warmer body is the cooler body, and how heat takes place in between this delta X we have to consider by using the Fourier's law is called as the Fourier's law of the heat conduction. So Fourier's law of the heat conduction state that rate of heat transfer by conduction, that is through a solid only, in a given direction is proportional to the area normal to the direction of heat flow and the temperature gradient in that direction. You can say that mathematically Q is directly proportional to that area, temperature gradient, and distance x in watts, or Q is equal to minus Ka dt by dx in watt, or you can say joule per second, or Q is equal to Ka delta T by L. Whereas in this equation, Q is the heat flow rate in watt, or you can say joule per second. A is the area normal to the heat flow direction in meter square. K is the thermal conductivity of the material in Weber per meter Kelvin. dt by dc is the temperature gradient in the x direction. Delta T is the temperature difference across the delta x, and delta x is the thickness of the material in the flow of the direction. You see that here. So you say that the delta x is temperature. Hello.
सर कुछ स्टूडेंट वेटिंग लिस्ट में उनको ऐड करिए.
Okay, 1 minute. Okay, added. So this is the cross sectional area you see on the screen. A is the cross sectional area of some thickness you have to consider. It's called a delta X. And K is the thermal conductivity of the material in Weber per meter Kelvin. So students, kindly write down this formula in their notebook. Fourier's law of heat conduction. Write this law: rate of heat transfer by conduction through a solid in a given direction is proportional to the area normal to the direction of heat flow and temperature gradient in the direction. And you have done all these three equations. There is Q is directly proportional to A dt by delta X in watt, or Q is equal to minus Ka dt by dx watt, or joule per second, or K is equal to Ka delta T by L. Minus sign is that temperature falls. Here you see that negative when temperature decreases with the increasing X. So minus sign is shown here, minus K. Okay. Kindly write down this statement in your notebook, because there is a simple formula. You have to enter all these values and have to calculate the answer. there are Fourier's law, Newton's law, one more is there the Stephen Boltzmann's law. तीनों लॉ के आपके न्यूमेरिकल्स है, तो आपको तीनों यहाँ पे लिखना पड़ेगा, तीनों लॉ, क्योंकि ये तीनों लॉ से ही आपको न्यूमेरिकल सॉल्व करना है, जैसे आपने हीट इंजन, हीट पंप और रेफ्रिजरेटर में सॉल्व किया था. Please write this statement and this formula also in your notebook. And also this annotations. That's Q is the heat flow rate in watt or joule per second. A is the area normal to the heat flow direction, that is in meter square. K is the thermal conductivity of the material in Weber per meter Kelvin. dt by dx is the temperature gradient in the x direction. Delta T the temperature difference in the delta x, and delta x is equal to thickness of the material in the heat flow direction. After completion, let me know so we can proceed to the next slide.
हॅलो सर,
हाँ
ते निगेटिव्ह साइन टेम्परेचर डिक्रीज होतं म्हणून घेतलंय ना?
हाँ, temperature decreases from one phase to the another phase as x increase, that dx, right? जो डेल्टा एक्स होता है ना, वो जब इंक्रीज होते जाएगा ना, तो आपका टेम्परेचर ग्रेडियंट डिक्रीज होते जाता है, इसलिए वो माइनस साइन लिया जाता है. आपका लिखना हो गया सबका?
यस सर.
ओके, ठीक है. नेक्स्ट, see this one. So inside how it is, you can say that warm 298 Kelvin, and due to some thickness, that is a blue thickness, this one, the direction of flow, it is about 273 Kelvin. So heat flow in this direction, so it outside is cold, and temperature distribution is to be linear, right? It linearly fall. So Q is equal to minus Ka T out minus T in by L. Also, you note down this formula, students. in which K is the thermal conductivity in watt per meter Kelvin, T is the temperature in Kelvin, Q by A is the nothing heat flux. ये आपको लगने वाला है, heat flux equation में आता है आपके. So heat flux is provided watt per meter square. So please, I am requesting all of you kindly note down this equation. QA अगर आता है Q by A तो आपका होता है heat flux. और मोस्टली प्रॉब्लम में हीट फ्लक्स प्रोवाइड किया होता रहता है, आपको यहाँ से टी आउट और टी इन कौन से भी एक टेम्परेचर कैलकुलेट करना होता है. And also note down this equation, L is equal to in meter is the distance. So you according to this equation, this Q is minus KD by dx in watts, or Q is equal to Ka dt by delta T by L. And also you note down this temperature in terms of T1 and T2 or T out in T in. So if you consider T out is minus 273 minus you consider at 298, so it's a flow. You can consider temperature decreases. So it's a negative, you have to consider for it as X increases. You also note down this equation. Once you note down the equation, we can proceed to the next point. Note करिए बच्चों.
यस सर.
ओके, सिर्फ आपको इक्वेशन लिखना है, उसके अंदर QA बाय A, K तो आपको पता है, T भी पता होगा, पर QA बाय A लिखो, हीट फ्लक्स होता है उसे, क्योंकि ये जनरली यही वर्ड यूज होता है प्रॉब्लम में कि हीट फ्लक्स इक्वल टू दिस मच. सो आपको थोड़ा कंफ्यूजन नहीं हो, इसलिए मैं यहाँ पे पहले ही बता देता हूँ कि QA बाय A इज नथिंग बट द हीट फ्लक्स. क्योंकि जब प्रॉब्लम सॉल्व करोगे तब बताओ कि सर हीट फ्लक्स कहाँ से आ गया, तो यहाँ से हीट फ्लक्स आता है. सो QA बाय अगर कंसीडर किया तो इक्वेशन की राइट साइड में क्या आता है, सिर्फ माइनस के टी आउट माइनस टी इन अपॉन एल. Now this is about one of the examples, T1, T2. That is how temperature and length determines, and K is equal to 0.96 vaporometer Kelvin. So if you specified any material, so they can give you directly the values. So is the turbine temperature T1 and T2? It's because Fourier's law, and it is a regard to the conduction, not a convection. Now, thermal conductivity means that it is the property of the material defined as the ability of the material to conduct the heat through it. Means some distance that is called as small s or delta x. So thermal conductivity is decreasing order is just like that, have a higher thermal conductivity of metals, then non-metallic solids, then have liquids, then lastly the gases. So gases have lower thermal conductivity. If question asked in your multiple choice question, that is in semester exam, so metals have a higher thermal conductivity whereas gases have lower thermal conductivity. Okay, this is for your information. ये पीपीटी आपको मिल जाएगा, पर इसमें आपको ऐसे स्टेटमेंट नहीं दिया है कि किसका हायर और किसी का लोअर है. सो काइंडली नोट दिस वन, दिस पॉइंट. Then higher conductivity in metals due to free electrons in their outer orbits, means number of electrons in our outer orbit is more, there will be a high conductivity. So in gases, whatever the electron molecules are less as compared to the metal parts. So metal have higher electron molecules free in their outer orbits, so have higher thermal conductivity. And K is strongly dependent on the temperature. K is equal to K0, 1 plus 80 or alpha T, I think so, right? So we have thermal conductivity, we have copper very high thermal conductivity 390 Weber per meter Kelvin. Aluminum has 240, where brass has 110, iron has 75. Metals have very high thermal conductivity. These are the 4 different metals with high thermal conductivity. Whereas the insulators have low conductivity. Air is a good insulator for your information, because the exam में पूछा जाता है कि air is a good insulator or not. So air is a good insulator, except that large air spaces allows heat flow by convection. So for using air is a good insulator only. And glass have very low thermal conductivity, 0.84, water has 0.60, wood has 0.10, and air has 0.023 have thermal conductivity. Is the air considered as the insulator material. Then move to the next point is the heat convection. As we discussed that when a fluid flows over a solid body or a surface, and the temperature of the fluid and solid surface are different, right? The heat transfer between the solid surface and the fluid takes place due to motion of the fluid related to the surface. मीन्स इसका सिंपल एग्जांपल अगर कंसीडर किया जाए तो मैंने जैसे आपको बताया कि एक यूटेंसिल है, एक पॉट है, उसमें अगर आपने पानी लिया तो जो सरफेस होता है आपका, जो यूटेंसिल आप यूज कर रहे हो, वो हीट होता है, और हीट होने के कारण जो फ्लूइड होता है उसको हीट अप शुरू हो जाता है। एंड जो पानी नीचे के सरफेस को टच कर रहा है, जहाँ पे हीट हो रहा है एक्चुअली आपका सरफेस, वहां से वो मूव करता है अपर सरफेस पे। वाटर के दो लेवल होती है, एक अपर लेवल जो एटमॉस्फेयर में होती है, जो सेकंडली बॉटम लेवल जो आपका यूटेंसिल होता है उसके बॉटम को पानी टच कर रहा है। तो जैसे हीट अप हो गया जाएगा तो नीचे का पानी ऊपर जाएगा ड्यू टू एयर डेंसिटी डिफरेंस। Water when heated have a lower density as compared to when it is in cold condition have high density. So it moves from bottom surface to the top surface. So it's called as heat convection by some molecules of the fluid. So that is called a heat convection. And if the fluid motion is artificially induced by fan or blower, then heat is transferred said to be a forced convection. Just like that, you can use the fan, right? अगर फैन के एक साइड में अगर आपने हॉट सरफेस रख दिया तो जो हॉट सरफेस जो वेव्स आएगी वो आप पे आएगी डायरेक्ट बाय मींस ऑफ फ्रॉम फैन और ब्लोअर। व्हाई? बिकॉज इज अ फोर्स कन्वेक्शन। इफ इट इज नॉट यूजिंग एनी फोर्स कन्वेक्शन then it's called as natural convection. If a fluid motion is set up by a buoyancy effect resulting from a density difference caused due to temperature difference in the fluid, heat transfer is said to be a natural convection. जिससे एक एग्जांपल मैंने आपको बताया, अगर आपने एक पॉट में पानी लिया हो, उसको हीटर करना शुरू किया तो नीचे का पानी पहले हीट होगा, फिर उसका ऊपर का पानी हीट होगा, सही है? तो इसमें कुछ हमने फोर्स अप्लाई किया है क्या, फैन वगैरह नहीं। सो इट्स नेचुरल कन्वेक्शन। अगर हम सब फोर्स अप्लाई कर रहे हैं बाय मींस ऑफ सम फैन एंड ब्लोअर और बाय अनदर मींस, इट्स कॉल्ड द force convection. Now, students write down this Newton's law of cooling. It regards with the convection. So, rate of heat transfer by convection from a surface to a fluid, and or vice versa, flowing along, it is equal to the product of the temperature difference between surface and the free steam of the fluid. The area of the surface normal to the direction of heat flow and the quantity H called as convective heat transfer coefficient. So Q is equal to HA Ts minus T infinity, or T1 minus T2 is simply in watts, where H is not a property of fluid or surface, but it depends on the properties of the fluid and vital dimension of the surface. So student, kindly note this Newton's law of cooling and its mathematical formula. सिर्फ 3 फॉर्मूला है कंडक्शन, कन्वेक्शन और रेडिएशन का, जिसमें आपको सिर्फ वैल्यू पुटअप करना है और कैलकुलेट करना है आंसर 2 और 3 मार्क्स के लिए। Please note and let me know so we can move to the next last part of the unit is heat transfer, radiation.
Okay, sir.
Okay, wait a minute. Huh? Okay, let's move to the next part. So that's about Newton law of cooling. So fluid flow from a surface, have some temperature, have some thermal conductivity, have some heat flow. Ts is always greater than T infinity, or second T1 is equal to greater than T2. Whereas A has some area over which the fluid is flowed. So Q, heat transfer flow rate in fact convection, is HA TA1 minus T2 in watt or TS minus T infinity in watts. So हम supposed to be एक area से consider किया, right? जिसका H thermal conductivity है, thermal conductivity बोला ना उन्होंने, and is called as convective heat. Okay, convective heat transfer है H आपका यहाँ पे, जिसका टेम्परेचर प्लेट का Ts है और T1 है, इसका A एरिया है. उस कंट्रोल्ड एरिया में अगर हम फ्लूइड फ्लो करें उस सरफेस के ऊपर से, राइट, तो जो यहाँ पे जो बॉटम सरफेस होगा जहां से फ्लूइड टच करेगा और अपर सरफेस, तो उसमें कन्वेक्टिव हीट ट्रांसफर होगा, राइट. तो कन्वेक्टिव हीट ट्रांसफर कैसे निकालते हैं? सो बाय यूजिंग दिस फार्मूला Q is equal to H, that is the convective heat transfer. A is the area of the plate, total area, length and height. So length and weight मल्टीप्लिकेशन करके जो एरिया निकलेगा वो एरिया, और जो starting temperature T1 minus T2 होगा. So you get that heat transfer rate, that is called as convective heat transfer rate. In this case, it's called as Newton's law of cooling. Now, Stephen Boltzmann's law. I think so you heard that black body. आपने एक black body concept सुना होगा. क्या पता है कि ऐसे बोलते हैं black body, perfect black body?
यस सर, जो
रेडिएट
रेडिएट जो ऑब्जर्व कर ले लाइट को, रिफ्लेक्ट ना करे.
Yes, that is the called as Stephen Boltzmann. Here is called as heat law of radiation. Okay, thank you. So please write down this again. Heat rate through radiation mode can be calculated by Stephen Boltzmann law. Q, or you can say it's capital Q, is epsilon. It's the emissive power of the black body. Your sigma is the Stephen Boltzmann constant. T raised to 4 A is the area. So आपको Stephen Boltzmann law is called as the law of radiation. तो उसमें आपको इक्वेशन होता है, इस इक्वेशन से आपको रेडिएशन हीट ट्रांसफर कैलकुलेट करना पड़ता है, where Q is the heat transfer per unit time in watt. You consider it is as a capital Q, don't write it small q. Q is equal to epsilon, so it is the emissive power, and sigma is a 5.6703 into 10 raised to minus 8 Weber per meter square Kelvin raised to 4. It's the Stephen Boltzmann constant. T is the surface temperature in Kelvin. Sometime is T1 raised to 4 minus T2 raised to 4. तो ऐसे मत समझो कि सिर्फ T रेस्ट टू 4 ही होगा. सम केसेस में क्या होता है, वो T1 रेस्ट टू 4 माइनस T2 रेस्ट टू 4 भी हो सकता है. और ये इज द एरिया ऑफ द इमिसिव और इमिटिंग बॉडी. So it's a black body radiations. So a black body is a perfect absorber of radiations, able to absorb the completely radiation of any wavelength that falls on it. And a black body not only the absorb the all wavelengths of radiation falling on it, but also radiates all wavelengths for its particular temperature too. So it's nothing but the emissive power of the black body. You know that. Simplest possible type of the black body is the hole in the black box. I think so. You know that experiment and painted black in the inside. And emissivity is equal to the actual emission of object at temperature T divided by the emission of the black body at temperature T. This is the formula of emissivity. Generally, emissivity is given in your problem statement, so they will not require such type of the calculations of calculation of the emissivity. Just write down this Q is equal to epsilon sigma T raised to 4 minus into A. तो ये इक्वेशन वहां पे पुटअप करो, ऑल वैल्यू पुटअप करो, जिसमें सिग्मा तो कांस्टेंट होता है, एंड कैलकुलेट द आंसर. So that's about the Stepan-Boltzmann law, or you can say that radiation law. Stepan-Boltzmann law associated with radiation. Newton's cooling law it is associated with it's called as convection, and lastly it's called as Cauchy's law. Fourier's law is associated with the conduction. So students, are you getting about all this concept of heat transfer?
Yes, sir.
Any problem in it?
Yes,
In
sir.
these three cases?
No, sir.
Okay. So I think that we have discussed the numerical of all these three laws in our next lecture. Okay.
Okay, sir.
Okay, sir.
Yes,
Okay,
sir.
Okay. You put your attendance in chat box and leave the meeting. We will discuss this numerical in the next lecture.
सर
In-
पोस्ट कन्वेक्शन क्या होता है?
क्या?
पोस्ट कन्वेक्शन, फोर्स्ड कन्वेक्शन.
कन्विक्शन चाहिए आपको. जस्ट मिनट, आप मीटिंग में बने रहिए. ओके.
हाँ सर.
Okay. Wait a minute.